Hello and welcome to this presentation. My name is Juliana Romero and I am currently a student at the Universidad Tecnológica Nacional, Facultad Regional Paraná, on the Civil Engineering Department. In this paper, belonging to the subject of English 2, I am going to talk about the topic that you can see on the title, urban heat islands, green roofs as a potential way to attenuate temperatures in cities. Having said this, we're ready to get started with the presentation. Green spaces add to the provision of ecosystem services in urban areas. Urban greenery encompasses parks, squares, street trees, and private gardens, and it comprehends a significant aspect of all cities. They allow us to mitigate harmful effects of environmental pollution by promoting air sanitation, cooling temperatures, retaining precipitations, and attenuating noise by its sound absorption capacity. Throughout the years and exacerbated by the population's growth, cities have increased the construction of buildings and streets to satisfy the people's needs. This way, green spaces have been displaced and reduced, and with them the benefits they contribute. If this growth were to occur without fundamentally addressing the climate impacts of intensified urban development and global warming, many cities will become much hotter and less livable. The United Nations 2030 Agenda and its Sustainable Development Goals have developed the path to stop and mitigate this heating process that is taking place in many urban areas of the world. More specifically, there are two SDGs that refer to this issue. First, we have SDG number 11 that centers around making cities and human settlements inclusive, safe, and sustainable. And then we have SDG number 13 that looks forward to taking urgent action to combat climate change and its consequences. The purpose of this paper is to develop a sustainable city model reincorporating the green spaces that had been displaced, aiming to mitigate the effects of global warming. To do so, a description of the problem and its causes and consequences will be introduced. This will be followed by the presentation of green roofs, used as a construction method that incorporates greenery in its structure. And in the last section, an evaluation of the effectiveness of this proposal will be introduced. It is expected that this paper may not only propose a solution, but it may also raise awareness of the importance of urban greenery. Due to the overpopulation and the consequent housing emergency, construction companies are supplanting the much-needed vegetated surfaces with more and more buildings made of low albedo materials. Albedo is the relative amount of light that a surface reflects compared to the total incoming sunlight. A surface with high albedo will reflect more sunlight than a surface with low albedo. Therefore, low albedo materials that are used for constructing high-density buildings are one of the major causes of increasing temperatures in the urban environment, known as the urban heat island effect. The urban heat island is a metropolitan area that is a lot warmer than the rural areas surrounding it. This is the reason it is theoretically considered an island. The temperature rise carries a variety of consequences that affect many aspects of an individual's life. Some of them are the increase in the electricity consumption due to the need of regulating the temperature inside the buildings in benefit of the owner's comfort. Here, a vicious cycle begins to generate, where due to the increase in temperatures, the necessity of air conditioning also increases. Then we have the reinforcement of climate change, because the increase in the electricity consumption adds to the atmospheric pollution and the greenhouse gas emissions. Then impact on water quality, because the transfer of excess heat accumulated in rainwater produces hot currents that are dumped into streams and rivers. It can also be harmful to the health of the ecosystem. And then we have the deterioration of human health, since heat waves generate discomfort, breathing difficulties, exhaustion, and even cardiac arrests. These high temperatures also generate certain conditions that, combined with other factors such as water storage and poor hygiene, cause an increased risk of diseases such as dengue, for example, nowadays. The lack of green spaces in highly urbanized zones increases the congestion and pollution daily, as we have seen, and consequently they impact the citizens' life. Therefore, the incorporation of urban greenery is proven to mitigate UHI effects. An innovative and less conventional way to integrate spaces for growing greenery are green roofs. A green roof is a building system with a plant finish on a bed of soil or substrate that is especially designed for obtaining environmental benefits. The plant cover may be total or partial, and it does not refer to terrace roofs with potted plants, but to building technologies for improving the habitat or saving energy consumption, either technologies that fulfill an ecological function. Green roofs can be classified according to either the type of plants desired to place or the structure in which it will be located. First, we have the extensive green roof that is recommended for building structures with limited load-bearing capacity and in areas with no or minimal regularity of use. It provides a meadow effect, which requires only low maintenance. Then we have type 2, semi-intensive green roof. It is used where there is the desire to create a pleasant environment that can be used by those working or living at the location. This roof is ideal for the creation of an outdoor living space. It utilizes basic plant types, which require more maintenance than the extensive roof. Moving on, we have the intensive green roof. It's a system designed as a landscaped roof garden, which might include an irrigation system. It opens practically all the possibilities of normal ground-level gardening, and it is ideal where a suitable, strong board-bearing structure is available. And next, we have the ground-level green roof. It is used in circumstances where substantial planting is realized using heavy mechanical plant and equipment during construction. It is considered suitable for ground level structures such as underground car parks. Every green roof must have a good composition of layers of suitable materials that provide it with a proper structure. So next, a typical build-up of a green roof model will be presented. On the top, we have the plant cover. The type of plants used depends on whether a low-maintenance extensive roof is chosen or an intensive one. The former is limited to succulents, grasses, and herbs, and the latter can be planted in accordance with the wishes of the gardener. Next, we have the substrate. The depth of growing media to use depends on whether the roof is the extensive or the intensive type. Soil depth can start from 40 millimeters upwards. Next, we have the root permeable filter fabric. It is a polypropylene fabric placed between the drainage layer and the growing media to prevent the media from migrating into the drainage layer and clogging it. The filter fabric must not impede the downward migration of water into the drainage layer. Then, as we've mentioned, we have the drainage layer that it's placed to quickly remove excess water from the vegetation root zone. Then we have the protection layer. This sheet is for mechanical protection of the water insulating layer during construction work. It retains moisture and allows roots to grow through, thus enhancing cohesion to the layers above. Then we have the root barrier. It protects the waterproofing membrane or insulation layer from root penetration. Then we have the waterproofing layer that prevents water damage through the deck layer. And there is a wide range of waterproofing materials, including hot applied rubberized asphalt, built-up bitumen, modified bitumen, thermoplastic membranes, polyvinyl chloride or PVC, thermoplastic olefin membrane, TPO, and elastomeric membranes. And finally, at the bottom, we have the deck layer. The roof deck layer is the foundation of a green roof. It may be composed of concrete, wood, metal, plastic, gypsum, or composite material. Existing buildings require the roof design to be studied so it meets the requisite load conditions. But either way, green roofs can be installed on a wide range of roofs, including those with shaded areas, with low load-bearing capacity, on high-rise buildings, with limited access, and even on sloping roofs. These sloping roofs must not have a slope over 45 degrees, otherwise it has to be considered as a vertical garden. An important aspect to keep in mind is that green roofs must be maintained. The frequencies of this maintenance vary depending on the chosen green roof, according to the type of green roofs described previously on this presentation. Now we're going to talk about the positive aspects of green roofs. Thanks to the ecological and economic advantages and free space they offer us, green roofs are beneficial for people and the environment. They also help to improve the life expectancy of buildings and their energy balance. One of the main ecological advantages that comes with green roofs is, as expected, the reduction of the UHI effect. This is achieved through the process of transpiration and humidification of dry air, which improves the climate and increases people's sense of well-being. Another aspect is the optimization of air quality through vegetation. It has been demonstrated that it is effective in reducing atmospheric pollution thanks to its capacity for filtering particles and absorbing pollutant gases. And then another positive aspect is that they also act as a storage tank for rainwater. Rainwater can be reduced through system technology for irrigating the roof itself or put to other uses such as cleaning or cooling appliances. They also prevent local floods. As to buildings, a green roof provides an extra layer of insulation. A hydraulic insulation is achieved because both the vegetation and the substrate protect the waterproofing membrane by alleviating the effects of temperature fluctuations. There is also an acoustic insulation improvement. A green roof reduces the reflection of sound by up to 3 decibels and improves acoustic insulation by up to 8 decibels. However, one of the most important building benefits of green roofs is their thermal insulation properties. This additional insulation reduces temperature and reduces temperature transfers between the inside and the outside of buildings. They reduce excessive heat during the summer and minimize heat losses in the building during the winter. This statement can be illustrated by the image we have here. It shows a green roof built over the City Hall of Chicago, USA, and the effects it has on the surface temperature, demonstrating a difference of 40 degrees compared to conventional materials. Green roofs can also contribute to roof longevity. They more than double the number of years typically needed before a roof must be replaced as compared with conventional and white roofs. Green roofs may present some disadvantages. They are assurance that the building can support a green roof, quality installation and leak prevention, maintenance requirements, and potential plant loss. Despite these issues, many involved citizens have been trying to implement green roofs on their urban landscapes. Although not all of them have achieved it, The persistence in spreading this proposal have been of great importance to achieve a change. Here there is a quote of one of the founders of the Rootscapes team in Paris that says, "To have any meaningful impact on the city, you must have a lot of roof terraces, but we have seen an evolution of the mentality around this issue. A few years ago, people weren't interested in climate change. Now they've realized it is urgent." Well, as a conclusion, we have to say that in this presentation, a critical view of the constructive development of the cities and the negative effects this has on the environment has been provided. Green roofs are presented as an important innovation in the construction world that not only have both aesthetic and functional benefits, but they also become a tool to combat climate change and its consequences. By means of this approach, citizens and urban planners have a better alternative with compelling positive impacts for sustainable urban development. Well, this presentation has come to an end. Thank you very much for your attention.